Hello and welcome. My name is Matthew Carli from LATICRETE International. I'm Director of Innovation and Strategic Planning. Thank you for having me here at Thinking Hut's virtual gala. I'm here to talk about 3D construction printing, and my title, The Trojan Horse That's Forcing the Digitalization of Construction. We'll walk through some of the mega trends that are happening around the construction industry and how 3D printing is influencing them. So real quick, for those who don't know, LATICRETE, it's a family-owned business. It's a global business. We have about 2,000 team members around the world, operating in pretty much every country with 20 business units producing material locally with local raw materials around the world. Mostly construction materials in the flooring space, so flooring installation materials for tile and stone, some concrete additives, and resinous flooring, some other decorative materials as well. So the agenda today, walk through some of these megatrends, what's happening also now with COVID-19, construction, global 3D printing, then some of the barriers that's slowing the adoption down, and the disruption potential that's out there. So COVID obviously has changed a lot of people's working behaviors, a lot of people's perspective on things. One thing, the silver lining with it is tech adoption is at an all-time high. Case in point, we're having this on Zoom. Most likely 6 months ago, this would have been an in-person meeting with me presenting in front of a crowd. So this is already quite a difference. But for a lot of people, it's working well. So we're seeing stuff like video analysis being brought right on the job site. Again, do we have the right PPE? Do we have face masks and helmets? Are people following the safe social distancing protocols? So you have sensors that alert people if they're not. We're also seeing an increase in modular construction, bringing more off-site and bringing more finished product to the job site, seeing the efficiencies there. Also, it's a more controlled environment, less people on the job site potentially, and looking at this then changes the perspective of a building being a one-off project into more of a product, so a manufactured product and less of just, okay, we're doing one single construction project. Also, just noting that there are even more advanced stuff. We're seeing autonomous vehicles. This is Built Robotics in the bottom left. They have autonomous excavation and other construction heavy equipment that's now being automated, so it's fully autonomous. Additionally, with this perspective changing, we're asking ourselves this finished product, what does it look like and how do people interact with it? So the idea of a healthier building and not just meeting building code or meeting efficiency goals, but also how does this improve the productivity, the life of the people using that building? So especially here we're talking about schools. There's been countless studies showing that better lighting, better air quality, better ergonomics really influence the learning and the adoption of what is being taught. So this is perfectly applicable, and I mean, we're seeing it from the lens of COVID-19 and how to make a building healthy, but definitely applies to schools as well. Another, can't go without saying, the world is definitely changing. We're seeing many more natural disasters, from wildfires to hurricanes, and population is continuously increasing. We'll definitely need more schools in the future, but also with the natural disasters and some of these instances happening, people are really questioning the efficacy of the materials we choose. So you look at the picture in the middle, the concrete house that was built independently and not the tract homes that got completely destroyed in that were meeting the minimum building code. The one in the middle that's home personal built, it withstood the hurricane no problem. So again, people are starting to change their mentality as these things are only increasing in frequency. Also with this, construction as a whole is seen as one of the least productive industries. It's basically flatlined productivity over the last 20, 30 years, but it's a massive, massive industry. So 13% of GDP globally is represented by construction. And with that low productivity, it's a huge arbitrage for venture capitalists and kind of the last frontier for venture capitalists as far as an area to invest in. So we're seeing just last year, 6 billion globally, thousands of startups popping up. Again, that increase of tech adoption as well. So this idea of the digital twin is only increased, with now 55% of companies saying that they're utilizing it in the next 2 years. But yet, still take this as it is, because construction is a very complicated product. The supply chain is not so simple. It's not, and each project is still a one-off thing. And with at least 80 trades, or on the average job site, 80 trades doing different work, that's quite a feat to optimize the whole process and get everybody working together. So there's definitely still challenges. So when we talk about this change in construction with technology, for me, and relevant to 3D construction printing, is really this single term, constructability. So this term is basically saying, well, how are we going to build the structure? It might sound rudimentary, but in the design phase, there's often breaks of someone's designing it, someone's saying, can this be structurally sound? Can we build it? And then it's passed over to somebody else to actually figure out how to build it. So with 3D printing and everything being a digitally native technology, you know exactly how the thing is going to be built. So whatever the G code is that's telling the printer where to place the material, that's what you're getting. So the as-built equal to the design. And we're able to ask this phase in a very iterative and early stage in design of how we're going to build it. So the process, the data is being always collected. The new technology, as 3D printing develops, all of this coming together is producing a more efficient way to build. Construction 3D printing is going to take over everything. There's a time and a place, and again, it's asking the right questions of when is it more viable. 3D printing is not going to replace tilt-up walls in the near future. Simple box type construction is definitely not an avenue for 3D printing, at least in the near future. In the near future, we're looking much more at highly complex builds, added value adds that you can only get via 3D printing. So again, it's this combining all in a digital platform that's unified. We're looking at design, and even the post-build world is starting to take notice that, hey, this data is available. What can we use it for? Seeing insurance companies asking these questions. Well, what materials are going in? How is it being built? How is it being constructed? Maintenance companies, property management companies are also starting to get wind that, hey, there's an amazing data source of everything that's going in the building, and how can I influence that? So it's the consumer on one side saying, I want this to look like this, and aesthetically and for utilitarian purposes as well, they design the building to their means. And then on the other side, this post-built world is also influencing and saying, well, if you use this material, if you use this practice, it's going to reduce your operating cost. So these are really coming together to form what is becoming an optimal product. Maybe it might change the paradigm of location, and it may be much more adding, again, these new thoughts into a building, maybe ergonomics, maybe operating, maybe there's a sustainability component to it. So the building product itself is being evaluated for what it is. I mean, in the past, location really dictated a lot of the development of the property, and now we're starting to see where these things can be somewhat separate. You can have the land itself, and that appreciates, depreciates independently from the actual product, the house that's being built on it. So a lot of new concepts being brought into how we look and evaluate construction. So what is 3D printing? 3D printing, essentially, you take that design, you splice it, you break it into layers. So the other term for it is additive manufacturing. So you take the computer model and you create what's called a G code. The G code is essentially an XYZ point cloud in space. It says, place this material here. Then you have a printer, the actual hardware behind it. In our case, this is a one-component system, so you just mix it with water. That's our LATICRETE 3D printing mortar. With a printer, this is our very early stage lab version, and then that becomes the printed structure. So again, the big so what of this, what's different, is the as-built is equal to the design. So you can use the digital twin and use it for any of those post-build scenarios that we mentioned, and again, it's matching up one-to-one. So why 3D? 3D printing productivity, we mentioned, is very low. So this is increasing productivity. It's less people on the job site. The schedule is also matching up to what was designed. So this idea of constructability is taking on many dimensions. It's cost, it's time, it's also material. So now we know exactly what is the yield. So if we have to bleed out a little bit of material in the hoses to get the printer up and going, then we know we have, let's say, a 95% yield. So as opposed to in the past, well, whatever was delivered to the job site, you had a much larger margin of plus minus extra material just in case things weren't exactly as planned. The speed is something like Moore's law here, where we're seeing print speeds that were 150, 200 millimeters a second just a year ago, 2 years ago, are now 300, 600. So we're definitely seeing the speed of the 3D printing, construction 3D printing, really increasing quickly. Again, something like Moore's law. The big thing with 3D printing across really all industries is the complexity. So it doesn't cost anything extra to do a unique project. We see this in the medical field with prostheses, with dental implants and stuff like that. Automotive is using it for prototyping. So in construction, it's, again, the luxury home market is something that's in and out of itself a massive market. And if this starts at that high end, where we're seeing like what we've done in Dubai, building one-off custom homes, this is a start to get the technology up and running. Logistics, so this project with Thinking Huts here in Madagascar, we have the ability to ship a printer down to Madagascar on a shipping container, be able to ship a concentrate or the material from mainland Africa, or potentially produce it on site in Madagascar, and print on site. So basically you're only bringing in a printer and that one component, local water, local raws, and build a school on site. So the future value adds is another major component of 3D. Aside from that complexity, you're able to now do things like sound attenuation via print design, or even further reduction of materials. So imagine a generative design that's using like a hexagon or a honeycomb type design. So all the voids would be excess area that you don't need material. You get all the structural strength, so a bunch of columns, a bunch of cones, and put all that together through the computer design, and you're able to use far less material. This is a couple years off still, but we're starting to see prototypes and conceptual papers being published from academia. So definitely on the horizon. The different types of 3D printer, there's really two that have coalesced as the main types of 3D printing. It's a crane system, sorry, a 6-axis robot like ABB or KUKA that's used in a lot of manufacturing environments, and then the gantry system. So the gantry system is an XYZ plotter using gravity fed. Sometimes there's an additional mechanism to control the dispersion of that extrusion. There are also alternative materials to concrete or cementitious based. There's soil, using local soil. This is wasp in Italy. There's hempcrete in Australia. Plastic with branch technologies in the US that's creating a positive mold. So, and there's still sand deposition and other types of 3D printing, printing in gel. So really a lot of different technologies. The two main for construction printing that have coalesced is the gantry with the XYZ plotter, or the 6-axis robot, both being extruded models, and that additive manufacturing being layer by layer. As far as global markets, definitely Dubai and the Emirates is a leader, having the Sheikh make a vision behind that 3D printing will be 25% of the construction in Dubai in the next decade. So we're well underway with this. There's a lot of companies competing for it, both industries, from the hardware side, the material side, academia is getting involved. So really that is been identified as a key market. Additionally, in the Netherlands, we're seeing a lot of development. Again, these private-public partnerships between universities, large construction companies, material companies, and others. And then Singapore as well, again, with government support giving money towards 3D printing. So our material that we've developed, right now we're up over 120 formulations that we've tested and worked with. Essentially a 3D printable mortar, you need it to be thixotropic, or at least under stress it has to flow. So you have to be able to mix it, it has to be able to flow through the pump and the mixer, through the hose, but then it has to be buildable. So at the point of extrusion, it has to hold its shape, no slump, and it has to adhere to the layer below it. So a lot of different characteristics of the same material in a really relatively short time frame. So from mixing to actually being extruded could be anywhere from seconds to just a couple minutes, and the subsequent layers being placed, again, seconds to a couple minutes. So it's really a whole new dynamic in 3D printing. Behind the scenes, there's also a lot to get this technology moving. So we're looking at certifications. How does it compare to conventional? Localization of material. So we're dealing with a heavy material that we can't ship very well. So using local raws where we can, and then R&D support from LATICRETE to get these materials working on the job site. So a couple of highlights. This is a pavilion that we did in with Ball State University. Chris Battaglia was the designer. And this is in Columbus, Indiana, for Exhibit Columbus. It's 110 unique panels, all weight optimized. So you see the voids on the top, there's less material because there's less force being put on those. This is the first house that will go commercially sold. This is in Dubai. This was certified with the Dubai municipality, weather tested to the desert conditions, and localized material. In India, we're 3D printing toilets with a project together with the government that's looking to make public toilets available to everybody across the country. And this is component systems, so like imagine Lego blocks that are stacked on top of each other. They're 3D printed off-site and then assembled on-site. So schools, just for me, the big opportunity I see with the schools in general, thank you, Maggie, for bringing it to our attention, is really the building itself can be the learning opportunity. So you look at something like a zero energy classroom, we're seeing it with energy consumption where people are monitoring the building in real time, and the students are using it, capitalizing on it as an opportunity to learn about the built world. So it's motivation to get people involved in construction, involved in engineering and material science. Also, there's definitely a need as population grows, we're going to need more schools. So it's a very great fit for construction 3D printing. Definitely, so the challenges, lab scale versus field, we're still very much in a prototyping stage, but prototyping a building that's a living space is very challenging. So you have to get everything aligned just right for the building for the prototypes to be built. So it's not an easy endeavor, and that's why we've seen probably less than 30 true structures be built via 3D printing to date. Building code is still something that lags, it moves slow. Standards as well, we're sitting on the boards of some of these to influence and make stay abreast to what's happening with with construction standards, but it is a long process, and it's also challenging, again, with the point above, that with so few projects to reference and the cost involved, it's kind of a chicken or the egg of what comes first. So places that are more open towards pushing the envelope, using, again, more of this computer-aided design that's going to give real insight to what's happening, that's where we're looking that 3D printing is going to be take its first steps forward. Also, the end goal here, the integration that's plug and play, mentioned before, at least 80 trades on a construction project. So replacing one of them, because what we've done so far with 3D printing is essentially we've done 3D framing. So we're printing non-structural parts of the building, potentially structural formworks. So it's one component, one of those trades is being replaced. It's not holistic printing of a finished structure yet. We are looking to incorporate other aspects in, but it's still mixing of an automated process, a digitally fabricated process, with conventional human labor. So looking at what McKinsey says for the disrupting factor, on a positive note, from 3D printing, it really hits all of these. We're reshaping regulations, we're rethinking how the supply chain works, we're optimizing things using technology, retraining workers, and looking at, again, the building from a whole new perspective. So a lot of really, really positive changes happening within construction. And again, 3D printing is not going to apply to everything. It's not the end-all be-all solution to save and build the buildings of every building of the future, but it is forcing us to ask these questions towards a really positive future. So I love this slide from McKinsey because it really hits, it's like a checkbox for exactly what 3D printing is doing to the industry. So I'll leave you with that. My contact is here. Please feel free to reach out. And again, thank you, Maggie and Thinking Huts here for this opportunity. And we're looking forward to more projects, more work with 3D printing. So thank you, and everybody have a great day.